Alright, so let's create our Unit 9 folder. Unit 9. And our package will be just like before. Will be chapter 9 dot. We'll call this the 2D arrays. Okay. Didn't like the dot. Okay. Didn't like the number. 2D arrays. There. And let's get a class in here. And again, I'm going to call it a two-dimensional array class. And then static main. Alright, so here we go. A little bit to the right over here. Alright, so what happened? Oh. Okay, so just review. This is 1D, and just for demo purposes, just do some numbers. It's easier. So we'll int here the bracket, and we'll put here some numbers equals, and we'll initialize it right away. So we don't have to declare the size. The size will be based on what we put in here. You separate each element with a comma. So here we put like a 2, 4, 6, 8, and then 10 even numbers. That's one array. And make sure when you do this, if you do it this way, you have to terminate with the semicolon because it's a statement. Okay? We do another one, int here. We'll call this maybe like points. Could be 200, 300, 50, and 100, and then 500. Okay? So, two single dimensional arrays have even number of columns. So we have 1, 2, 3, 4, 5 columns. And the first one is sorted, the second is not. Okay, so to get the length of these will be just again numbers.length or points.length will give you the number of elements or slots in the array. Again, the index is always the length minus 1, the maximum index. And once you declare this way, then you are fixed at that length or that size. You cannot change the size. In other words, it cannot be resized. You can remove the elements, the data, but that slot is preserved and you can't truncate it. At least not in Java. In other languages, you can. Okay, so that's one-dimensional array. And then two-dimensional array. Very similar. In here, we just say int. Again, it has to be with the same data type. So int of, you can say integers. And you can declare like we did initially. You can say, you know, int and then bracket bracket. Okay. So if you do it this way, if you do int bracket bracket, oops, not that one. Okay, you have to give it a size. You don't have to give the size for both of them. You have to give the size at least to the first index. It needs to know how many rows. The second one is optional. That can grow, but the first one has to be fixed. So if I put like a, for example, 2, then, oh, I forgot the word new here. I said new. Then you're good. Okay. If you don't know the columns, then you can leave that blank because that can grow. But if you don't put anything there, then you cannot just do that. Okay. It won't let you. It won't like it. So that's how you do it. If you know, then you can say, oh, it's a 2 by 3. You put that there, and once you do that, it's fixed. Okay. So that's one way. Now you can also do like this way here by using the literal declaration. So let's just say that I'm going to remove this and put that in here. Okay. And if you just leave it like that, then it's a array of 0. It's still two-dimensional, but it's 0, 0. So now, so in here, the first group, if you follow this same pattern here, right? This is an element, a second element. So it's a 2. So the first element here can be a numbers. So I can put the numbers in there. Okay, and then the second would be the points. Now this may be a little bit confusing because the declaration, if you take out the variable name, it looks just like a one-dimensional declaration, right? And the reason why this works fine is because these are already arrays. So again, is an array of arrays. Now this can be really clear. Let me just copy this down here. We'll give it a new array, like down here. We'll give this like integers 2. And so instead of doing this, this is the same thing as saying I'm replacing this number with this whole list here. So I copy that, put it here. Right? I'm doing exactly the same thing. I'm using a variable, the other I'm using just literals. Okay, so these two are identical. So when you declare arrays, you can do it this way. If you want to reuse this again, then put that into a variable like this, and then use it the first option because maybe you want to, modify the arrays, the numbers and points. If you don't, then you can just do it this way. It's quicker. And as you add more and more to the list, sometimes it becomes very hard to see. And so you can always break this down into multiple lines like this. You can do that. And usually that helps because it helps you visually see this in a very, very nice pattern. Again, the numbers are kind of like way off, but if I do this, if I align the columns, you see that it has the number of rows and columns. Okay, that many rows. I have 2 rows and I have 5 columns. So you kind of at least have a visual way of displaying that data in a table. Okay, so that's completely legal, allowed. So that is a two-dimensional array. And then if you want to print out the arrays, let's just say the integers, either one, they're the same number, then you need 2 loops to do that. Okay, one for the rows, the number of rows, and then one counter for the column. So it's always going to be two loops. One will be nested inside the other loop. And you can use the while loops, for loops. You could mix and match either the loops, either way. So, but it's very common to use the for loops because we know exactly what the sizes are. If you don't know the size, then again, that's usually the while loop. But so we can say for integer I, just a counter. You can use I, very common. Sometimes you can put row. Maybe let me put row here. Okay, so row, starting from row 0, all the way to row is less than the size of the integers. Okay, so now again, because it's two-dimensional, so you have to measure one of these rows here. This is a squared array. They have the same number of columns, so it doesn't matter which row you use. And it's always safe to use the first row to get the size. So that will be integers of row 0 dot length. Okay, and that will give you the size of the array, number of columns in there, and it's going to be the same for every row. So because it's a squared array, and then row plus plus. So that is for the row. You're going to loop through that row 0 first, and then for that row you treat that as a single dimensional array, and then now the second loop will be looping through that row through the columns. So now here, and then for each column, starting from column 0, and then the size of that array, let's see, I think will be probably the same. So column less than equal to the integer of 0 dot length, and then column plus plus. It doesn't look right. Okay, yeah, it doesn't look right, but because this we're checking the length of this. We're not going that many times. We'll only do like 1 and 2 times, right? So 1 and 2 rows. So really, this shouldn't be shouldn't be that many, because if you do that, it's going to get the entire 5 times, and it's going to have an error because we don't have the many. Just basically it's just 2 rows, okay? And I think that'll be just the integers dot length okay, the dot length versus 0 dot length, and we'll see what that gives us, because I think one of them is can't forget, one of them is the length of the columns, one is the size of the column, one is size of the rows. Yeah, because this one gives you the number of columns. So if you just put a dot length, it gives you the number of rows. Okay, so it's a little bit tricky when you do this one here. Okay, so this is the number of rows. If you don't put the index, the subscript, if you put the subscript in there, then it's going to count the number of columns for that. Okay, that row. So now we can go ahead and print this out to the console, and we're just going to print the integers of I and j. No, rows and column. Row, column. And we'll put, yeah, so let's put it in every line. And we're just printing the first one. So, I mean, it doesn't matter which one, it's the same numbers. And if this is correct, then if we run it, we should get those numbers out to the console. So here is the numbers for that. And okay, so from 2, 4, 6, 8, 10, this is the first row, and this is the second row. And it's not nicely printed out this way because of the formatting with the print line. And if you want to format it nicely so it will look something like this on the printout, then you have to put a print here followed by space, and that should give you that outline. So you can move that print, you say print here, print the first number followed by a space, and then after that, first every row, you just have to print a blank line. And if you do that, then you have a table, well, almost. At least now each row is displayed in a row-wise layout. And if you also want to print the second one, so copy this, put integers 2 here, and you just get a duplicate row, because this is yeah, it prints twice, right? Because it's the same number. So sometimes this can get really fun, and you can play with this. You can swap the rows and column instead. Okay, so I want to remove this again. It's confusing. So instead of so right now I'm printing row-wise, right? I'm going row by row. If you want to print column-wise, you go through every column and print the row that way. Then all you have to do is basically you swap this 2 here. And then you get a different output. That means if you put like you put this outside here like that, so you get column-wise. Okay, just by swapping the two loops there. So again, depends how you want to do it. And if I ask you to print like diagonally, like just make sure you know you have to do that. There's different ways of how you can print the arrays in many ways. Okay, so we'll do one more, and then this time let's change these numbers. Let's just say this is 12. We'll keep that as is. This is like 26, and this is we'll keep that as is. This one will be like 100, 200. This is 550. 100 is the same, and then we'll print this to be what you say 600. Okay. And so we can look through this array, this against this one here, and we compare this number against this number, and we'll print only if they are equal, right? So you can print the numbers when the numbers are equal in both arrays. If they're not equal, then we ignore them, right? So again, it's very simple. Once you do that, then that's good. So here, before we print it out, you can say so how would you do it? How would you compare this first one versus this one and check if they're equal? If they are, then print it out. Otherwise, you're just going to skip it and you move to the next group. How would you check that? Okay, so this one here is, oh wow, not good. So it gives a very simple way to do it, because it's a squared array, and we're certainly comparing the first one against the first one, second against second, and so on. So right in here, before we print this out, we only print this out if it's equal. So we can do like that, and then like that, right? Print that out. in either one because it doesn't matter which one. So here we'll say if the integers array of I and j, again row column, or if that one is a value in that slot, that means in this cell is equal to this cell here. So very simple, equal the integers 2 dot row and column. If they're equal, then we print them out. So that's all there is to it. Okay. Otherwise, we ignore it. You move that to the next one. Okay. So if you remember last week, this is like in a parallel array. So it's a parallel two-dimensional array because a single index controls both of those arrays. So if you print that out, it only prints the one that are duplicates in each of these. Is that right? No. Oh, obviously integers 2 here. 2. Okay, I'm just printing against itself. So integers versus integers 2. And it should print only those are similar in both tables. So 4, 8, 10, and 100, and the rest are not the same. Same in their slot. Okay, it could be you know, in a different slot. We don't check for that, but we assume that it's in the same slot. Because certainly 200 is the same in both tables. And so is 100. And in the same slot, they're not. So if I ask you to look through both arrays and find all the numbers that are common in both arrays and then print them out, then you will have to do it differently, right? You will do the algorithm differently. And I mean, just to kind of look at that, how would you do it? So you can compare all the numbers here against all the numbers here and print all the numbers that are identical. If they match, print it all out. Okay, it would be different. That means you have to look at this number and then go through the entire list here, compare them all. If it's the same, print that out. You move to the next one. You do the whole same thing again, move the entire list, and then the next one, and so on. So you have that, again, big O to the N to the square notation thing, right? So you have to compare one number in every case, one number in every of those elements, and compare them that way. So you have basically, it's a 4 nested loop inside. The first 2 here will be just for the outer loop, the other array, and then inside will be another 2 loops for the second array. So you have like 4 loops. All right, so we're just dealing with numbers, but the concept is the same for every other element, other types like doubles, strings and characters and objects. All the same. Here we're just dealing with numbers. I could have this, you know, it's a table of sandwiches, right? Sandwich objects. So we have a table of cars, right? So each car will be an object itself. So you have a car class and car object in there, and then you can access that and then do something with it. Okay, so this will be similar to the assignment, the mini project, where you do the horse racing, right? This is the horse racing here. Like this is the number of horse number 1, horse number 2, and then the first race, second race, third race, fourth, and the 5th race. Okay, so you find through that first row, first race for the horse number 1, and see how many zeros, 1s and 2s and 3s. Okay, so any questions before we take a break? And then we'll come back after the break. We'll do the array list. All right, so let's take, what, 5?